Our next speaker is Hyo. He's a software engineer at Facebook, where he works on tooling for GraphQL to allow developers to use it at scale. He's also the maintainer of the very popular open source GraphiQL, which is a graphical UI for exploring schemas. That has also been called, I think, GraphQL's killer app. So welcome, Hyo.
All right. Thanks, guys. All right, let me just do a couple of in-house settings, but not. Cool. All right, how you guys doing? Good. All right. I'm excited because I get to talk about what I did for past whatever time. So my name is Jeong. I'm a software engineer at Facebook. And tonight I want to talk about how GraphQL powers the development at scale at Facebook. So hopefully everyone here knows about GraphQL, yeah? I can get a consensus of, I know GraphQL. I've been to some talks about it. Maybe you have some experience. And hopefully you're stoked about it, because I'm definitely interested and very excited. But I'll just summarize it just one more time. And it is a query language that aligns with the way that product developers think. And it's amazing, right? And at Facebook, we are using GraphQL to power many applications and platforms in production today. For instance, in fact, we power all our mobile applications with GraphQL. And its type system, the schema, it plays a huge role in defining just what we can do with the data. But what I want to talk about tonight is how the type system is useful in client side. So you know that GraphQL type system defines the capabilities of an app server emitting data. And using this type system, we get to query, edit, and do other many cool things with the data you have. But knowing how GraphQL types are defined in client side, it can be a very incredible, powerful platform for building tools that can support the product developers. And I'd like to introduce some of the tools we built to support the native client development. And these are native client-side code generation and graphical, but in scope of Facebook and the scale of Facebook. And lastly, I want to do a little sneak peek for you guys to do a GraphQL IDE support that I've been working on for the past couple months. So meanwhile, I'd like to also address, got one right here, sorry. I'd like to address the problems we've had operating in such a large scale and what we did and learned from them. First, let's look at the client code generation. So in here you see this diagram. We don't just have many requests and applications. We also have several native devices that you have to support. And what we learned is, for each native devices and clients, it needs a way to understand and model the request being sent to the server and responses sent back from the server. And from working with several different devices, clients, and developers, we've learned that it is very much possible to automate this process of generating the native code from introspecting the type system on the client side. This is roughly how our toolchain looks like in Facebook. We built a toolchain library that powers our native client-side development. Its job is very simple. You have a type system, the capabilities, and files that contain GraphQL queries. And the toolchain generates files used to send out the query requests and types that model each response from the execution result. And it's very relevant, actually, to say it is powered almost exclusively by GraphQL.js, our reference implementation, and just pure vanilla JavaScript. So having said all this, right, you might ask me a question that says, why do we want to do this at all, right? Why do we want to model these GraphQL artifacts? Don't we already know the structure of the query and the responses that we receive, right? So I want to do an interactive session, kind of. I want to kind of quick show of hands. How many of you kind of did this and are familiar with doing something like this? Yeah, like this is only a natural response to, this reads as you send the HTTP request, you get back some kind of response, and you parse the JSON, and then you render view with that. So unsurprisingly, this was our first approach too, to sending a query and rendering with the responses. And you could possibly guess this, this gets quickly out of hand. Because there are many issues to solve as a team gets bigger and the product scale grows. So what if we have a huge query? Then we have a logic to go into the, in this case, in friends and go get the names. And if they have more friends, then we get more friends. It just gets out of hand. And then what if we have more than a couple teams working together, right? Then we constantly go into merge conflicts. You know, you solve your conflict, I resolve my conflict, and it's not going to be organized. So soon after we started adopting GraphQL to Facebook, we came across these questions ourselves and realized that, you know, we may need to have a way to intermediately represent these queries and responses. So I want us to take a look at an example. So this is a pretty simple query, right? It's a query that gets a user with an ID and name and list of friends with the name. And this is how we model our query requests. So I'm not actually sure what language that is. I'm a JavaScript developer, so that looks terribly like JavaScript. But you see how the query is wrapped in a very thin class with some helper method to set the arguments if you want directives. And then you have an execute method to help with the actually sending the query. And then when the query is sent to the server, and in the rendering code, it executes it with the callback when it's finished. And this simple thin wrapper, even though very simple, it becomes super helpful since many of our queries are reused in production to fetch data for, let's say, timeline, photos, and the newsfeed, things like that. So this is roughly how we model our query requests, but how do we approach modeling our responses? And this is like the simplest diagram that to illustrate how responses are composed from the server. We have a server, and using the custom parser that we built from the toolchain, we can model the intermediate representations for our responses. If you think about our type system, though, and how it powers our queries going out, it only makes sense to translate those types in client-side to mimic the kind of an introspection of our type system, right, which is a schema. So naturally, we do something like this. So that's an example query or fragment in this case. And since since a name field and friends field, it returns user types. Well, name returns string, and friends returns a list of users, right? So it makes sense to create a user model that's used in parsing the response of this query fragment. And we call this a type-based model. And note that even though we're only querying for name and list of friends and name for them, we have methods to get other information, such as current city, the age, and list of pets, more than one. Because other queries must have queried this field within our universe, right? And then and making this type like a source of truth, the type to go, right? This becomes very problematic over time. And before I show you why it is, I'd like to show you a new approach we're taking to model the responses, which is a fragment-based model. And it looks like this. So you see the same example fragment, name and friends. And instead of trying to know which natural type each field returns, a fragment-based model takes a single fragment or query or a GraphQL language and tries to model just that. You can see there's a class of a fragment, and there are methods to get only the information you've queried, only the information you need to render the view in the original fragment. And it models the friend. So in friends and name, it's getting list of friends. What it tries to model is the friend from the list of friends returned as another representation. And doing this, we suddenly separate the concern of having to know the return type you get back from the query or fragments, since all the information you need would be modeled within it.
And I want to show you kind of how they compare to each other in terms of when you have your render implementation logics and it tries to fetch the information from the responses. So same exam fragment. You have type-based model and you have fragment-based model. And when you try to get name, it calls the getName method in type-based. And similar enough, it gets name from the fragment-based. And same for this, right? We get the list of friends by calling each method responsible for it. And here's where it starts getting interesting a little bit more. Because note that in order for you to get the list of friends, since a friend is your user, you need to access an entire object to follow that. Whereas in a fragment-based modeling, you have another intermediate representation for the friend. And then this just gets a name at the end. So in the example fragment, you saw that to get friends, you needed to refer to the user class, right? But what you see here is another limitation of the type-based models, which is that in order to operate with the type-based models, you'd have to build one giant library that includes all the type models and have implementation code refer to this library. So one quick example is from the example you saw over here, right? What if we wanted to query or ask for page info? What if we wanted to know the profile picture, right? Then just knowing about user type is not sufficient. You have to go into the schema, find whatever type you want the information out of, and then include in your library or just know about them. And it quickly becomes you have to know all the types in your system. Whereas in by using fragment-based models, each model becomes a library of its own. And you can already see how it becomes a lot modular than having one giant library for all the models compiled. And I want to illustrate another problem, which is, so this is an error-nest situation, right? It's trying to, the yellow highlighted part is that shows the implementation code trying to get the list of pets, right? But in the query or fragment, you haven't queried the information. So I'm showing you this because the fragment-based model definitely avoids this problem of underfetching. So assuming this code is the rendering code, the bottom code, used in client-side, in type-based models, there's no way to catch this error unless this code gets into the production and runs only to find out that we didn't query for pets information. And in fragment-based model, we can catch this bug while the code is being compiled to run since we haven't generated the getPets method because it wasn't queried. So kind of summing up all this, I want to show you kind of table view of the pros and why we chose to use fragment-based model. Number of models you have to know for type-based is maybe multiple. It doesn't have to be one. It could be many. But in fragment-based, you have one per fragment. Overfetching and underfetching problem, it's very, very difficult to solve when you use type-based model. But in fragment-based model, you solve overfetching by statically analyzing your query being used. And underfetching, you just come across it when you're compiling. And talking about modularity, in type-based model, you have one single giant library, like I told you about. But in fragment-based, you have one library per each fragment, which becomes a lot usable. Yeah? Excited? Yeah. All right. Yeah. Let's talk about GraphQL. Yeah? I love this tool, by the way. GraphQL it's helped me a lot. But in Facebook, we have certain limitations, and I want to share you what they are and what we did to solve them. But first of all, Facebook GraphQL schema is huge. It is enormous. How large it is it's 70 megabytes. This is pretty big. It's 70 megabytes when uncompressed, and 200 megabytes before we open source this syntax, we had another syntax, and for that syntax, the schema gets 200 megabytes.
this is pretty big, right? And since GraphQL is powered by a GraphQL type system, the introspection of it, we need this information, right? So to mitigate this issue, we did a couple of things. We did one thing is we allowed GraphQL to be usable without having the type system. We can execute the query, and that was about it. And we can run the validation in the execution time, and that was about it. But GraphQL has so many features like type heads, validations, and linting, and documentations. They all need schema to run. So next natural response is, hey, let's cache this, right? We do server-side caching. We do client-side caching using IndexedDB. But one problem we couldn't solve by doing this, memoizing, is when you're trying to parse 70 megabytes and 200 megabytes on browser, it freezes. And how bad it is recorded a little something for this. Yeah, and that's not my computer crashing. It's a legit browser just like giving up. And I can show you more, but this goes on for 20 seconds. So, and that was how bad it was. So the solution we're using in production right now is parsing that JSON file incrementally as the HTTP stream goes sends the pieces of it, and we call this streaming JSON parser. So the idea is instead of blocking out the main thread JavaScript for parsing, streaming JSON parser breaks up the work into multiple pieces so that parsing continues without having to reserve the main thread for the considerable amount of time. And let's just see it in action. So same schema is loading, and kind of look at from the cursor blinking that it's completely usable, immediately available for you. And so yeah, this just improves user experience tons, right? From 20 seconds to what, half second of blinking, it's a win for us. But going further about that is we only use this to invalidate the browser cache and update just the recent changes. So we're pulling down the cache and using that to power the GraphQL. And then we, in the background, we run this JSON parser to get the schema and parse the schema. And as soon as it's available, we serve it up to cache and invalidate it. Fair warning is like trying to get the unready state change and trying to get like some characters per whatever take. It becomes 3 times slower than actually calling JSON parse. But the win is over here. The user experience is just a whole lot better. Cool? All right. So some of the things GraphQL at Facebook does is to, okay, first of all, you just saw deal with the huge schema, and second of all, provide hooks for support for experimental features. And what you see over here is subscriptions. That's my wall post, and as I type, you see the comments being updated live. And I only wanted to show you this, not to promote subscriptions in any way, because it's still very early in stage and it's an experimental feature. But if you wanted to play with this idea, because it's been out there, and I know some of the open source communities are playing with this idea, GraphQL tries its best to be up to date with the specification or experimental features that GraphQL or GraphQL spec documentation suggests. And it's available in GraphQL today. All right, who loves GraphQL? This guy does. This is such a good GIF, sorry. For I say GIF for no reason. I guess I should play it to make it better. But yeah, this shows you what you can do. Exactly what you can do with the GraphQL, right? It can do typo heads. It can autocomplete leaf node. It can lint and validate the queries as you type. This is pretty neat, right? It's pretty cool. What if you can do this in your own IDEs? What if you have Nuclide, you have Atom, you have IntelliJ or something that you can work with this and have this feature. So I want to kind of show you a little bit of a sneak peek and preview of what I've been working on for the past couple months, which is the GraphQL language service. And I know live demos are bad, but I should do a live demo. So here it's I don't know if you can see this, but it's a test.graphql file. And I have just this experimental language service I'm developing enabled. And you can already see the syntax highlighting. Thanks to Robert Mosogo in the open source community, he built this syntax highlighter for Atom. I'm just frantically using it. It's amazing. Yeah, you already see the lint, right, over here. And this is a syntax error that you see from the graphical, right? And since this contains a storage schema, the swappy that's available in open source, let's try querying something, hero or human. I practice with humans, so let's go human. And I try to query what ID, right? And there is an error says, well, you need some kind of ID as a string. So let me go add that in. ID equals to, and without friends, it's no me, so let's get some friends. And it could be a lot better without being in the menu, but another thing we can do, because this is all JavaScript, this is all reference implementation, we can autocomplete leaves right here, and it does this. Pretty cool, right? All right, demo's over. Thanks, all right. I'm excited that you're excited because this is, I want this to be, so my goal for this is, you know how GraphQL has this whole community of GraphQL tools and GraphQL clients and servers. I want this to be another community, like sub-community, so that we can gather the language services for each IDEs and we can share them, we can improve them together. And yeah, and what you can do in GraphQL, you can do in just in your IDE of your choice. So that's all I have today. These are some links, helpful links that you can take a look. On top of is Slack. We occasionally hang out these days, and we try to be more available. Ask any questions over there. GraphiQL link. And then if you just came across GraphQL and if you wanted to know more about it, learngraphql.com is an amazing website you can go to. But last but not the least, GraphQL.org. And I want to close off by saying we don't have all the answers. So we can only improve, and GraphQL community can only improve if you guys can contribute and support us, and with the amazing tools and amazing servers and all this like mind-breaking stuff. And please reach out to us or any of the GraphQL community people if you have any ideas, questions, concerns, just improvements. And yeah, I thank you for your time. Thanks for having me.
All right, questions?
Oh.
No.
This is so.
Hi, thanks for the talk.
No worries.
I was wondering how Facebook manages a schema that large when you don't have, I don't know, namespaces or really, like you can't have name clashes. So how do you deal with a 200 megabyte schema? That must be a crazy number of types and interfaces. And
so, all right. So I guess the question is, Facebook schema is pretty huge. How do we deal with that? And before answering your question, I'm gonna just come out and say I have a couple of Facebook GraphQL members in this audience, and we're gonna hang out. Please raise your hand if you are here. So you can go ask them the questions, but I'll try to answer this question because, so Facebook schema is huge, and how we manage it is just like this, just solving as we come across, right? So this problem is specific to GraphQL and browsers, so we solve it by doing all this. And then when we're generating code and running services and running servers, they also have their own problems, sets of problems, because I'm going to talk about code generation because that's what I've been working for. And when we were generating code, there are some considerable amount of time that we spend to build and compile and know and parse and visit using the visitor, all those good stuff. And they actually take more time than we'd like it to be. So it's really just without context, it's hard to really answer, and that's where our GraphQL members can help you. And I guess my short answer is we just solve it and manage it as we go. And we also understand we have the largest schema out there. So it's really about learning from the mistakes. Maybe we make some mistakes, learning from the mistakes, and really developing all these. I'll say best practices or like some things, some decisions we've made to, and we like to share that. We like to talk about this like this. We'd like to manage it in a way that, I guess the shorter answer is we don't know all the answers again. Well, we're just coming across with them and solving them as we go. I'll hang around after this so I can answer more questions.
I was just wondering, how do you get set up with GraphiQL? Is it like a desktop application that you download, or is it like you'd put it into your development and it'd be like facebook.com/GraphiQL?
All of those above. I can answer this question. It is right now, if you go to that link over here, there's a standalone, I think Swappy enabled like a test GraphiQL page you can go to, and it's a basically npm package you can download and you can embed it to your applications if you're developing with it, or if you want to develop with it. It can also be, I don't see why not it can't be a desktop application, and it could also be just a tool to bring your schema in and fire up a localhost server, just local server, and start using it right away. It could be anything.
All right, we have time for one more question.
Cool. So on the topic of like the Facebook schema being so large, have you ever had to like rewrite the schema? So I know like GraphQL is really good, like where you can just rewrite the resolver functions if like your application backend changes. But what happens if you have to like rewrite your schema entirely when it's that large?
Good question. So the question kind of boils down to, the whole answer kind of boils down to what we're doing right now at Facebook too, because I mentioned briefly that we had this legacy syntax and that was like 200 megabytes. It's better now and it's 70. We saved like whatever, 60%. I can't do the math. You do the math. But so we saved that much, but it's still large, right? And then the rewriting is only possible when we actually migrate. So we're in the process of migrating ourselves. Migrating specifically from the legacy syntax that we have to the new open source syntax. And since the code base is huge, we are slowly taking steps to get there. But after that, I think a couple of the ideas that we're thinking about is, one of them is not rewrite, but maybe unload the time to parse the JSON, and then using like a visitor or parser in GraphQL.js. And we've got to do like we got to monitor which is like the better way to do it, right? But we're playing with a couple of ideas. We don't have the exact answer yet, but yeah, we're just hoping to get the right answer for that. Yeah.
Okay, let's thank Hyo again for his great presentation.